Hi everyone, this is lesson 7.3, similar right triangles and the geometric mean. In this lesson, we're going to learn what happens about some special theorems that happen when you have a right triangle and an altitude drawn from the hypotenuse to the right angle, or from the right angle to the hypotenuse. So your learning goal is to use properties of altitudes of a right triangle to identify similar triangles and then use the geometric mean theorems to solve problems. All right, so here in the picture below, there are three similar triangles. We're going to draw the three triangles separately and mark the corresponding parts and then complete the proportions below. So also, if you would like, I also posted the lesson notes in today's folder. So if you want to print them off, then that might be helpful to some of you so that you don't have to draw the original triangle again and some of the triangles and theorems later on in this lesson. But if not, just make sure that you're taking good notes and drawing everything accurately. So you've got triangle ABC here. It's a right triangle because the right angle is at B. And you also have an altitude drawn. So BD is the altitude because it goes from the top, the vertex, and then straight down at a right angle to the hypotenuse. So we're going to take, so you've got a large right triangle here, but then since this is a right angle, you also have two other triangles. You've got this medium triangle on the left, and you've got this smaller right triangle on the right, right? And they both have a right angle at D. So for triangle ABC, we're going to draw it so that it's oriented with the right triangle, with the right angle in the same position. So for example, I'm going to take this triangle and draw it like this. Also, I do recommend using a straight edge for this so it looks a little bit better. Oops, wrong button there. All right, so B is your right angle. And then A is the longer leg of this triangle. So I'm going to put A over here. Also, when you do draw the right triangle, make it so that one leg is shorter and the other leg is longer, rather than isosceles looking. And then C is the shorter leg, or the vertex from the shorter leg. All right, so that's the large triangle, the big triangle. Now we're going to redraw the triangle on the left so it's oriented in the same way. So I'm going to kind of copy the same triangle. I could just make a right triangle. Oh well. So short leg, long leg, and hypotenuse. All right, so what is the right angle of the medium triangle? That'd be point D. And what's the point going up from the short leg? Would be point B. So this is point B, and then the long leg is DA. Sorry, should be D, sorry, DA. I'm also going to label. So I'm going to say that this is the long leg, short leg, hypotenuse. Okay, so this is long leg, short leg, and a hypotenuse. So you see where we're going with this? We're kind of redrawing the triangles so that they're oriented the same way. Okay, and then we'll draw the small triangle on the right. So the right angle for the small triangle is at D. I don't know why I keep calling it B. That's D. The short leg is DC, so this vertex here is C, and then this one would be B. So once again, this is long leg, short leg, and hypotenuse. All right, so let's answer some questions below, comparing the two triangles. So first we're going to compare triangle CBD, the right triangle, with the left triangle. So the first ratio says that AD over AD to BD. So AD, am I missing something here? Oh, here's AD. Okay, so AD is the long leg of this triangle. BD is the long leg of this triangle. So this is going to be our long leg ratio. And then CB. So if CB is the hypotenuse here, then we need to name the hypotenuse over here, which would be BA. And then CD is the short leg over here. So we're going to name the short leg over here, which is BD. Right, so now I want you to notice something. I want you to notice the two ratios where one of the side lengths repeats itself. So that would be the first one and the third one. So do you see how BD repeats itself? So we're going to take special attention to these two ratios, and I want us to look at what those ratios are in the original diagram. So this point up here was point B. So this says AD to BD. So AD to BD. So AD is part of the hypotenuse because the altitude splits the hypotenuse into two pieces. So AD is part of the hypotenuse. BD, BD, I'm looking at the wrong thing. Sorry, AD is part of the hypotenuse. BD is the altitude. Okay. And then BD is the altitude, and CD is the other part of the hypotenuse. So this ratio is saying the ratio of the altitude to this part of the triangle is equal to this part of the hypotenuse to the altitude, right? That's going to be significant here in a minute. So the altitude to this part equals this part of the hypotenuse to the altitude. Okay, let's compare the left triangle to the large triangle. Okay, so AD to AB. AD is the long leg, AB is your long leg. BC. BC is your short leg, so we'll name the short leg over here, which will be DB. And then AC. AC is the hypotenuse, so we'll name the hypotenuse over here, which is AB. All right, so let's look at these these ratios, and notice that the side that repeats itself is opposite again. So one is in the denominator over here, the other is in the numerator over here. Well, spoiler alert, that's called a geometric mean when it's on opposite parts of the proportion. So let's look at the original diagram and compare those two. So here we're saying AD to AB. AD is part of the hypotenuse. AB is your long leg. And over here, AB to AC. AB is your long leg. AC is the whole hypotenuse. So this ratio is saying the ratio of your long leg to the whole hypotenuse equals part of the hypotenuse that's adjacent to the long leg. And then we'll do this last one. Now this last one is going to be very similar to the long leg, the second one, except it's going to use the short leg. So we'll compare this triangle to this small triangle. So CD to BC, that's going to be your short leg again. CD to BC, and then this will be your long leg. So AB to BD, and then AC is your hypotenuse to BC. So look once again, your geometric mean is the opposite parts that are equal to each other. So BC repeats itself. So BC is the short leg of the original triangle. So we're saying the short leg over AC, the whole hypotenuse, equals the segment of the hypotenuse the short leg is adjacent to, which is CD, over the short leg. So once again, short leg, hypotenuse, part of the hypotenuse to short leg. So in other words, the short leg is the geometric mean between the whole hypotenuse and the part of the hypotenuse it's adjacent to. The long leg is the geometric mean between the whole hypotenuse and this part of the hypotenuse it's adjacent to. And then your altitude, BD, is the geometric mean between the two parts of the hypotenuse. So the altitude proportion only uses the parts of the hypotenuse, not the whole thing. All right, so I know that's a lot to take in. Let's look once again. The geometric mean of two numbers is the number x that satisfies that, where our geometric means were the altitude, the left leg, and the right leg, or the short leg and the long leg. So in the figure above, the following are geometric means. So the altitude is the geometric mean between AD and DC. So we'll write AD and DC. The left leg is the geometric mean. So this is the left leg, is the geometric mean between the whole hypotenuse AC and part of the hypotenuse AD. So AC to AD. Okay, so once again, these two are the parts of the hypotenuse. Part of hypotenuse. AC, the left leg, uses the whole hypotenuse and the adjacent part of the hypotenuse. Adjacent means the part that it's next to. And then the right leg uses, once again, the whole hypotenuse, and then the other part that it's adjacent to, which is DC, the adjacent part. All right, and then one more little summary of this, and then we'll do some practice problems. So the first one was called the altitude geometric mean theorem. And I'm going to switch up these letters so that it corresponds with the letters that we used in the original diagram. So this is going to be B, and this is going to be C, B, and C. So the altitude geometric mean theorem says in a right triangle, the length of the altitude from the right angle, so BD, is the geometric mean between the two segments that form the hypotenuse, so AD and DC. So the way to write this, whenever I write using one of the geometric mean theorems, the altitude of the leg, I always set up a proportion first. I say, okay, what goes in the geometric mean? That's going to be, in this case, the altitude, so BD. So we'll put BD here and BD there. And then the other parts are going to be the two parts of the hypotenuse, so AD and DC. Okay, and then the leg theorem says that in a right triangle with an altitude drawn from the right angle, BD, the length of each leg, so AB, is the geometric mean between the whole hypotenuse, AC, and the segment of the hypotenuse it's adjacent to, so either AD or CD. So let's do the long leg. So for the long leg here, I'm going to assume that that's going to be AB. Set up a proportion. So they're saying that the long leg is the geometric mean, so AB over AB, between the whole hypotenuse, AC, and the part of the hypotenuse that's adjacent to AD. And then for the short leg, we're going to use BC. So BC is the geometric mean between the whole hypotenuse, AC, again, so these two both use the whole hypotenuse, but it'll depend on what part of the hypotenuse it also uses DC, whichever it's adjacent to. So DC is adjacent to AB, AD is adjacent to, sorry, I meant BC. You know what I mean. All right, let's do some practice. So I know that took a while to explain, but I want to make sure that we go slowly because this is always one of the harder concepts to get. So, and we'll also be doing some practice with simplifying radicals. So for part A, when we solve these, we want to ask ourselves, are we going to set up the theorem for the altitude, or are we going to set up a theorem for the leg? So in this case, we're trying to find part of the hypotenuse, but we're given a leg, so we're going to use one of the leg theorems. So we're going to say that I'm going to set up a proportion, and the leg is the geometric mean, so 6 is going to be the geometric mean between the whole hypotenuse, which is 12, over the part of the hypotenuse adjacent to, which is A. All right, so you can cross multiply, or I see that we can simplify first. So this would be 12 over 1. So this would be 2a equals 6, which gives us a equals 3. For number 2, obviously here we're given the altitude. So we're going to set up the altitude theorem. So this says that the altitude x is the geometric mean between the two segments of the hypotenuse that it splits up, so 6 and 8. Okay, cross multiply, x squared equals 48. Take the square root. Now 48 is not a perfect square, so what's the largest factor of 48 that is a perfect square? That would be 16. So we would write it as the square root of 16 times 3. And the 16 can come out as a 4. So this would be 4 square root 3 simplified. Number 3, find W. Well, W is the altitude, so we're going to use an altitude theorem again. So we'll have W plus 9 and W plus 9 as the geometric mean, and then 8 and 18. Now be careful, remember from algebra that you can't cross simplify. That doesn't work like that. You can only cross multiply. You can only simplify if the fractions are divided by each other, but these are going to be multiplied. So 8 times 18 is 144. And then x plus 9 times x plus 9. Remember from algebra that we have to do it like this and FOIL. So this would be 144. First outer inner last would be w squared plus 9. W squared plus 9w plus 9w is 18w plus 9 times 9 is 81. And then you're going to subtract the 144 over. And look, we've got a quadratic equation. So 0 equals w squared plus 18w. 81 minus 144 is negative 63. And then we ask ourselves, and then we factor. So what are factors of 63 that add to 18? That's going to be, if you check on your calculator, that's going to be 3 and 21. And since we need positive 18, the 3 will be negative. So there'll be w minus 3 and w plus 21. And then you set each factor equal to 0 and solve for w. So this would give us w is 3, w is negative 21. W can't be negative 21 or that'll give us a negative altitude. So the answer is w equals 3. And it just said to find w. So that's it. All right, AD. Find AD. So AD is an altitude. Oh, sorry, no, AD is not an altitude. AD is this part. Okay, so there are a couple ways that we could do this. So we've got this leg here. So we're going to use a leg theorem because we don't know what the altitude is. Okay, so let's go ahead and set up our leg theorem. So let's do a proportion. Our leg is the geometric mean, so that'll go in the opposite sides. And then we want the whole hypotenuse. Well, what's the whole hypotenuse? I don't know. So let's call it AC for now. So AC, and then the part of the hypotenuse adjacent to would be 5. So the idea here is that we're going to find AC, and then to get AD, we'll just subtract 5. So cross multiply. So it'd be 5 AC equals square root 35 times square root 35, just turned into 35. Divide by 5 and you get 7. So if the whole thing is 7, then AD is going to be equal to 2. All right, and then One more here. Find AC and DB. So to find AC, that is the whole hypotenuse. So think for a minute. Do we need to use one of the geometric mean theorems in order to solve for AC? The answer is no. You can just use Pythagorean theorem, or if you know a little bit about the Pythagorean triples, the 3, 4, 5 triangle. In the last video, I explained how any multiple of 3, 4, 5 is also a Pythagorean triple. So if this is 30 and this is 40, then the hypotenuse is going to be 50. Okay, so that one was quick. AC equals 50. Now the next thing we want is dB, which is the altitude. So let's do some brainstorming here. So if we want the altitude, we can't set up the altitude geometric mean theorem because we don't know what AB and BC are individually. And there's no way right now I guess we could find them. But the other way we could do this is we could figure out what AB is and then use that with the Pythagorean theorem to find BD. So let's then set up a leg theorem using 30 as the geometric mean. I'm going to say 30 and 30 is the geometric mean between the whole hypotenuse, which is 50, over the part of the hypotenuse is adjacent to, which is AB. All right, now before I cross multiply, I'm going to simplify 50 over 30, which is just going to be 5/3. So cross multiply, you get 5AB equals 3 times 30 is 90. Divide by 5, and you get AB equals 18. Okay, so that's fantastic that we got that, but that is not the final answer. We then need to find what dB is. So we can just set up Pythagorean theorem. So we'll do 18 squared plus BD squared equals 30 squared. And then if I subtract the 18 squared over from 30 squared, I get that BD squared equals 576. Take the square root of that. And luckily for us, if you take the square root of 576, what's it, 576? Yes. 576 is in fact a perfect square. So the answer is 24. All right, so after this, there will be another optional video that you can watch that'll help you with some of the other questions in your Edulastic. But other than that, the next thing that you'll do is the Edulastic the next day. All right, so hope you enjoyed this lesson, and I hope you have a great day.